Assalamualaikum and very good morning. So for the class today, we continue to our vector calculus, how we can use the vector calculus to line integral. So the first of all, integrate a function along a path, curve or line, so with respect to the arc length. Okay, so an integration okay, so this one is represent for the mass of the straight line from the certain point A to B, which is the fx. So fx, this one fx. So this line represent for the potential function. Okay, potential function. So or this one in 2D, and this figure show for the 3D. Okay, so this line, the red line represent for the potential function fx. Okay, fx. So this one fxy. Okay, this one fx. So this one fxy. So they represent either in the 2D or 3D. Okay, so the ds here represent for the arc length. So ds represent for the arc length. Okay, so the reason this one here, they have the two variable. Okay, so the reason how we can integrate the line, so we need to change from the two variable, we change to the single variable. Okay, we need to change to the single variable. So how we can change for the sy to the single variable? So we need to the parametrics. Okay, parametrics. Okay, parametric equation. So we need to change the variable of the x and y in the term of the t, so ds here, ds represent for the arc length. So arc length here represent for the arc length, ds. So fxy, we need to change in the parametric. So this one in the plane 2D. So for the surface is the 2D, 3D. Okay, this one 3D, the same thing. So we just only focusing either in the 2D or 3D for the line integral. So line integral, this one we need to integrate here, integrate bawah dia. So yang ni bawah line, the bawah line. Okay, so the start from A to B. So this one, let's say this way. So the start A to B. So the start the 0 to pi, 0 to pi. Yes. Okay, this is the formula. How we can change from the two variable or three variable in term of the single variable. Okay, so actually this one is the represent kalau you dah pernah buat this one. Okay, here you dah pernah buat, kalau you dah pernah buat sebelum ni, this one adalah represent for the r prime t. Okay, magnitude of the r prime t for the arc length formula. So if you know, this one represent for the arc length, ds. Okay, so this is the formula. So how we can use this formula to determine for the line integral? Okay, so we need to look the some example. Okay, compute. So they given the cy ds, where c is x equal t square, t cube, y equal t, and okay, t start from 0 to 2. Okay, this one for the 2D lah, for the 2D, because they just have the x and y. So the formula you need to determine here. I usually determine this one first lah. Okay, x prime t kuasa 2 plus y prime t kuasa 2 dt. So I determine for this one first, and then I comply with this formula and then solve for the integration. So you know the x equal t cube okay, y equal t, so x prime equal 3t square, okay, y prime equal 1. Okay, and then you need to square prime square, so equal 9 t power of 4. So this one y prime square, you get 1. So you insert this formula dt, so 9t 4 plus 1 dt, and then baru you substitute into integration, start from 0 to 2. So y, no more y, because you want to change from the 2 or 3 variable into the single variable. So single variable, so we need to change in the parametrics. Okay, parametric. So y you change in parametric, so the t lah. So t, so this one t kuasa 3 okay, y kuasa 3, so y sama dengan t, so t kuasa 3, and then you bring all this as a ds, this one ds, so bring ds, so you can get set 9t power 4 plus 1, so d dt, this one equal to ds. So you back balik semula, so dia dah dapat, so all here equal to ds. So function x, y, z atau function for the xy you change in the single in term of the t. Okay, dah settle, so barulah you boleh integrate. Okay, so you integrate here, saya just bagi jawapan saja. So your final answer is the 1 for the 44 145 set 145 minus 1. So this is the answer. So how to integrate, saya tak terusik lagi sebab just single integration, takkan tak tahu lagi kan. So it's simple. So this one example for the A and example for the B. So let's say example this one 2D 3D pun sama. Okay, 3D, let's say it's the 3D. They given the x, y, z. Okay, ds. So ds here ds. Bila you look ds, you know lah, you need to find the line integral. This one line integral respect to the arch length. Okay, so the given ds where c is x equal to sin t, y equal t, z equal negative 2 cos t, and t from 0 to pi. Okay, this is the question. You need to solve this one. Okay, to solve this one, bila ada ds, so tahulah this one line integral respect to the arch length. So the idea you need to find lah this one. Okay, this number 1 ni. Okay, so you letak x equal to sin t, y equal t, z equal negative 2 cos t. Okay, so x prime sama dengan 2 cos t, so y prime equal 1, z prime equal 2 sin t. So you square kan x prime square, so you dapat 4 cos 2t, so y prime square, so you dapat 1, z prime square, you dapat 4 sin t. So you jadikan ds here, set sambung saja, so 4 cos t plus sin kuasa 2 t plus 1. Okay, dt, so you know this one equal to 1, so you can dapat 4 tambah 1 5, set 5 dt. So settle. Okay, ds dah settle. So now x, y, z lah. X, y, z you need to change in the term of the t. Okay, parametric. So dia punya limit start from 0 to pi. So x 2 sin t, y t negative 2 cos t. So you just masukkan set 5 dt. No, you already form the line integral in the term of t, the parametric equation, just single variable. Okay, so 0 pi, so you simplify, and phi. So this one jadi negative 4t sin t cos t dt. Okay, and then you need to solve this one. So you look here, cos t dt ni, cos t dt here. So this one you can change using the trigo identity. Okay, where is the sin 2t equal to sin t cos t. Okay, so you can use this trigonal identity, and then finally you can get negative 2 sert phi integration 0 to pi. So this one I just simplify after I substitute with the trigonal identity, and then you get this one. T sin 2t dt. Okay, betul eh? So this one cos ni jadi negative 2. Okay, 2t sin t cos t. Okay, here all here equal to sin 2t. Oh no, t here, t, this one tak ada t. Okay, so dia 2t sin 2t, sin 2t. Okay, sin 2t. Okay, and then you bring out negative 2 here, so t remain. So you, okay, this is the, after you simplify you can get this one. So you need to solve this one, t. So this one by part lah. So you need to solve using integration by part. So your final answer is the sert phi pi. Okay, so try selesaikan So saya just tunjukkan how you can form the line integral. Okay, from the 2 or 3 variable you need to change into the single variable, ataupun you need to parametrize the equation to get the t in the term of the t. Okay, this is the way. This is simple lah, because they give the direct. Okay, the direct, what is the x, what is the y, what is the z. Okay, okay, let's say I give the another example. Okay, settle. So let's say the given evaluate. Okay, evaluate line integral. Okay, c x square plus y square ds, where c the right half curve, x square plus y square equal 9. Okay, so this question, the c is the right half curve, x square plus y square equal to 9. Okay, so this is the question. So the given here, so you know ds, ada ds je, integral respect to ds. So you know this one adalah line integral respect to the arch length. So you dapat the right half curve of x square by y square. This one circle circle kan, this one circle. So dia nak sebelah saja, half right. Okay, sebelah. So yang ni lah. Okay, so this one. So dia punya boundary, this one r square. So r square, so r equal to sert 9, you get 3. So half lah 3. Okay, so this is the curve. Selalu counter clockwise. Okay, dia punya curve, this one. Okay, so you need to integration. So this one half curve. So kalau circle, for the polar coordinates you tahu the polar coordinates, so you tahu lah x equal r cos theta. Okay, and y equal r sin theta. So you need to change in the parametric in the term of t. So the theta you need to change kepada t lah, sebab dia movement t0, t1 contoh. So theta this one you change dengan t. Okay, so you can jadi x equal r cos t, y equal r sin t, and then you need to r radius. So in this question the radius is the 3. So you can get for this question x equal 3 cos theta, y equal 3 sin theta. Okay, so you dah already change to the parametric parametric. Okay, in the term of the t. Okay, this is the way lah. If the question related to the circle, so you need to change in the parametric. Okay, so you dah dapat. So you need to determine for the ds. So ds, you x equal 3 cos t, y equal 3 sin t. So x prime negative 3 sin t. So y prime equal 3 cos t. So square kan, x prime square 9 sin square t. Okay, y prime square you dapat 9 cos square t. Okay, so this is your x square y square, and then you need to find the ds. Ds equal to this one 9. So you just simplify sin kuasa 2t plus cos kuasa 2t. Okay, so dt. So this one represent for the ds. Okay, so sin square t cos square t equal to 1. So you can get set 9 dt. Okay, ds sama dengan ds lah. So ds dah settle. So you need to substitute here. Okay, substitute here because you want to change in the parametric. So x and y must be changed in the term of the t. Okay, jangan you tukar pula x kuasa 2 tambah y kuasa 2 sama equal to r. No, don't change to the r because we need to change in the t term, bukan not in r terms. So this one you need to change in the t terms. Okay, so set 9 ni sama dengan 3 dt. So sama dengan ds. So you dah settle lah ds. So term t not r jangan berpandai s square per r square, nanti you confuse. Nanti macam mana you how you want to integrate when you letak sini r pula kan, r square lepas tu 3 dt. So the question need to you change from the two variable in the single variable in the term of the t, in the of the t, not in the r. So x and y square you need to change in the t lah, t term. So t term you look at the right side. Okay, you look here. You look here, so in the right side, so x t cos theta 9 3 sin theta. Okay, so you change lah x square dengan y square. So you akan dapat x square 3 9 cos kuasa 2 theta plus dengan y square 9 sin kuasa 2 theta. So this one you square kan, square. So ds sudah dapat sama dengan 3 dt. So this one you can be simplify. So see the start form here lah, ni here. So berapa theta ni? 0 to 2pi. Boleh 0 to pi or 0 to pi ataupun sini 3 pi per 2 So this one pi per 2. Either one lah. Mana ni one 180 lah, senang sikit, 180 degree. So 180 degree, so 0 to 2pi. Senang. Either one lah, mana you rasa selesa. Tapi saya selesa sebab this one 180. So the start 0 to 2pi. Okay, 0 to pi. So 9. So cos kuasa 2t you dapat 1. 9 you multiply dengan 3 dt. So 0 pi 27 dt. So kosongnya 2 pi. So you akan dapat 27 pi. So this is the way lah. This one simple, saya selesaikan lah. Yang paling panjang you kena selesaikan lah. Okay, so you can get the answer is 27 pi. This is the way lah how you can solve for the line integral if they given in the curve. Okay, another one, the question, if the question given a segment. Okay, they given the segment. Okay, so settle ni last kali untuk topik hari ni. We continue how we can direct integral if the question given the line in the term of the segment. Okay, so the given here, compute line integral C 2xy ds. So ds lagi sekali tengok ds. Saya punya hint kat situ lah, the ds, so you tahu this one adalah line integral respect to the arc length. So where C is line segment, okay, negative 2 1 2 1 3. okay, kalau kita sketch graph, negative 2 1 point here hingga 1 3. So this line lah, line ni, okay, xy. So 1 3, so this one negative 2 1. So dia nak you integrate this line, okay. So the idea is still same. So you need to change from the two variable, in the two variable you need to parametrics change into the single variable in the term of the t. So if the question like this, line segment, okay, line segment from the negative 1 to 1. So when we need to change for the parametric equation, so we can find this one is the initial point. So the t can start from 0 to 1. So this one initial, this one the final. So t can start from 0 to 1. So this point adalah t equal to 0, this one t equal to 1. Okay, this is the first thing. And then the second one, you need to find the component x and y. Component x and y. Component x and y. So what is the purpose of the x and y? Because we need to find the ds. So how to find the ds? So we need to determine component x and y in the term of t. Okay, so we need to parametrics x and y. What is the parametric equation for the x and y? So for this one, this is my technique lah, how we can determine for the parametric equation. Usually I can find the line. If the line integration, a line function, so the line function, so you know the line function is equal to y equal mx plus c. Is it? This is the basic equation for the line function. This is the function for the line. So I use this one. Okay, so let's say at the point t equals 0. Okay, t equals 0. So t equals 0. So in the term of the x, okay, saya akan change this one dalam bentuk x. So x akan jadi x equal, okay, because we need to determine in the term of the t. So they can get C1 is the intersection lah, plus K1 is the boundary. So multiply with the t. Okay, saya akan tukar dalam bentuk ni. The basic here lah, basic here. So you akan tukar mx ni jadi kt lah. Okay, don't want lah, kalau nak senang, takut you confuse kan, saya tulis dalam bentuk sini lagi senang lah. Okay, saya change in the parametric equation based on the basic function for the line integral, basic function for the line. Okay, so this one for the t, x akan jadi x equal kt. Okay, x ni kita nak jadi t plus c1. Okay, so this one for the y sama juga, t equal 0, so y akan jadi y equal kt1. Okay, kt k1 k1 t1 plus c1. Okay, this is the basic how you can derive, obtain ataupun form the parametric equation. So you need to write lah, y equal kt plus c1, x equal kt plus c1, and y equal kt plus c1. So because we want to determine for the component x and component y. Okay, so when the t equals 0, x is the negative 2. Betul, x equal negative 2. So this one k1 K1 kita tahu, so T equal to 0. 2 equal to 0 plus C1. So this one cancel out. So you can get C1 equal negative 2. Okay, settle. Negative 2. So you dah masuk dalam formula ni. So you tahu X equal K1 T minus 2. Okay, selesaikan ni. And then you use T equal. Okay, so you guna, and then you guna T equal 1. T equal 1. So when the T equal 1, so X equal 1. Here you tengok ni, X equal 1. So you masuk sini 1. So K1, so T akan jadi 1. So negative 2. So K1 equal negative 2 masuk sini jadi 3. So K1 equal 3. So finally you can get the parametric equation for the X. X equal 3T minus 2. Okay, settle. This is the way lah how you need to determine the component X and Y in the term of T. Okay, similar with the Y. Hijau lah. Similar to the Y. Okay, similar to the Y. So sama juga kita letak T equal 0. So Y pada 0 1 1. So K1 T dia kosong. So plus C1. So cancel out. So C1 equal to 1. So you dah dapat bentuk Y equal K1 T plus 1. And then you use T equal to 1. So at the T equal 1, Y equal to 3. Y equal to 3. So K1, so T equal to 1. So plus 1. So K1 for Y equal to 2. Okay, K1 for the 1 equal to 2. Tolak, so K1 2. So you can get the Y equal K1 to 2T plus 1. Okay, 2T plus 1. So you already get the parametric equation for the component X and Y. For the X and Y. So you can solve lah. Okay, so X equal 3T tolak 2. X prime sama dengan 3. Okay, X prime sama dengan 3. X prime kuasa 2 sama dengan 9. Okay, so Y equal 2T plus 1. Y prime equal to Y prime kuasa 2 equal dengan 4. Okay, so you setkan 9 tambah 4 dt. This one represent for the ds. So set 13 dt. Okay, and then you substitute dalam ni. So C start from 0 to 1 because you dah already in the dt. So 2 X equal to 3T tolak 2. Y equal to 2T plus 1. So set 13 dt. So this one akan jadi 016T tolak 4 2T plus 1 dt. So set 13 dikeluarkan lah. Set 13 dikeluarkan. So this one you can expand lah. Expandkan. So ni kali ni, ni kali ni, ni kali ni. So nanti basic je lah. Basic integration. So dia dapat 12 T kuasa 2 plus 6T, okay, minus 8T minus 4. Okay, so integration 01 set 30 dt. So you integrate one by one lah, integrate ni, integrate ni, integrate ni, integrate ni. So and then you can get the answer. Ni jawapan saya tak dapat so cuba dapatkan jawapan dia. What is the answer for this one? So the important thing, this one basic lah, basic how to integrate ni basic. Okay, the important thing how you can find the parametric equation for the x and y. Okay, this is the way lah how you can determine for the parametric equation for the x and y. If the question given the line segment, so you kena baca betul-betul soalan. So if the question given the line segment here, so barulah you boleh guna this method. Kalau dia bagi line macam previous question given the curve, so you need using the x equal r cos t. Okay, r tu represent for radius lah, what is the value for the radius, and then sama you need to determine for the ds. So ds equal set x prime t, okay, cos 2 plus y prime t cos 2. Kalau ada z plus lah, plus z t, okay, cos 2 dt. Okay, this one. So you can solve ni and then you substitute here, become as the single variable. Okay, and then you can solve lah for the line integral. Okay, let's say for the three independent, if the question for the tadi line, okay, and now I want you to solve for the three line, letak soalan 3. They have the 3. Okay, they have the 3 Okay, so you try to solve this one. Okay, they have the segment 3. Sama je, kaedah the same thing, but they have the x, y and z. Okay, so you need to solve this one for the try at home. So solve. Okay, so evaluate c x y z kuasa 2 ds, where c the segment 1 1 0 2 2 3 1. Okay, so this one, so you tahu biar ds, so this one the line integral with respect to the arch length. So this one given the segment, so automatic you can t start from 0 to 1. Bila segment so you tahu you can change x equal to kt plus c. Okay, samalah y sama dengan kt plus c, z equal kt plus c. And then you solve this one, and then you determine for the k and t by using the t equal 0 and t equal 1. T equal 0, you look at the point lah, berapa. This one for x, for y t kosong, y equal 1, t1, y equal 3. And then you can determine the parametric equation for each x, y and z, and then barulah you solve for the ds. Lepas solve for ds, you look back here, so all these things must be changed in the parametric equation t term. So you change, tengok balik sini, x sama dengan apa kat sini, y sama apa, and then finally you can form the dt lah. So 0 1, so you form dt, then you can solve lah as the basic integral. Okay, that's all for today, and try this one at home. We will discuss for the next meeting, next lecture. Thank you all.